My name is Jepsen, and I'm the CEO of Pixel. We had a new startup that was basically combining two mature technologies, silicon and liquid crystals, and basically slopping the liquid crystal on the silicon to make a high-res display that's really low cost and make wristwatch video or head-mounted displays, or put them into HD TVs for very low cost. I did that and developed that technology for about a decade. Nicholas Negroponte founded the MIT Media Lab. He had built these schools in Cambodia, and because they were off the grid and with no roads, rather than giving computers, he gave the kids in these schools in Cambodia laptops, and he was amazed at how their education was transformed. And the laptops were key because there was no power. You needed something that would run with very low power. And so he said, wow, if we could just make a $100 laptop, then countries could buy these en masse and give them to the students in their countries like textbooks. The world's information is digital, and only rich people can get to it. There's 6.5 billion people in the world, and a lot of them can't afford computers or computing devices or what have you. We want to get everybody across the digital divide. I started working with Nicholas on this to create the laptop to make it cost $100, because the problem in hitting the cost point of the laptop was in what a lot of people don't even consider to be part of the hardware of the laptop, the screen. The average cost of the screen in the laptop is more than $100, and also the big power hog. And so if you're going to make a low-cost laptop, you've got to start with a screen. In the development of the laptop, we obviously focused on lowering the cost, but more important than that was dealing with two aspects of infrastructure: the power grid or lack thereof, and the internet grid or lack thereof. Half of the children of the world live with little or no access to electricity. For the laptop to be usable, it had to work on next to no power. We made a bunch of alternative power systems for getting to recharge the laptop. You can charge the laptop with a car battery, a small hand crank, a small solar panel, a foot pedal, a cassette that attaches to a bicycle, wind power, water power, animal power. In India, there's not a lot of bicycles, so kids can't sit at the back and charge up a bunch of laptops at the same time, but they've got cows that walk around this rotor to make electricity to charge a car battery that then they use to charge the laptops. Integral to the laptop is mesh networking, and what that means is internet signals can hop from laptop to laptop to laptop. We have these little rabbit ears that pop up out of the laptop, and they give us 3 times the range of a typical laptop. You know, the idea of a global humanitarian effort producing this piece of hardware, a very high-tech hardware, is really unusual. What we've shown at OLPC is that rather than innovating at the top of the pyramid, where you spend several $million to create a prototype of a one-of-a-kind prototype of something, is that you can innovate at the bottom of the pyramid and work on low cost. You can make really interesting things that aren't just stripped down, low end. You can make things of high quality and really rethink technology, architectures, and so forth. It's widely believed that this new class of laptop will be 25 to 50% of the laptop market by 2010. That's huge, and that was with $25 million of in-kind support for R&D efforts, even though the people throwing in the money thought we were just going to make a stripped-down laptop. But the really big, insight that's somewhat obvious is if you ask new questions, you get new answers. And so if you let people skilled in their area at a new area to try to serve the bottom of the pyramid, what you might get is a home run that just is useful from the bottom all the way up to the top.